Hello and welcome back to my Kubernetes series. In my last video, I built a container for Postfix and completed a detailed look at our deployment of said application. We walked through the init container, which creates some of the files for our final deployment. In this video, I want to start off right where I left off and discuss the config maps, which will complete the deployment. As there are quite a few and some of them more complex than others, I will point out while reviewing these files how they connect to the deployment and why they are needed. So let's dive right into these files, switch to the terminal, and start off with the config map for the database connection files. Vim postfix db and paste the file, and we have it in here twice, so we're going to delete everything down here and we'll start at the top. As you can see, this file is really straightforward. We have a kind config map. We call it cf configs. It is deployed in the namespace mail server, and the data looks as follows. First, we have a server address. This is the connection to our database cluster we deployed earlier. We have a port, we have a database name in which the details or the tables can be found, and then I declare configuration files and their queries. The configuration files are identified by the variable cf name and defines the name the file will receive while the script is executed. These two items are followed by numbers. Depending on how many different entries the create.cf.sh script finds, that many files will be created. As you can see, we find 6 database connection files, one of which we still have to deactivate. And the one we deactivate was virtual mailbox maps. That's the one we out-commented in the script earlier, and we have to do the same with the cf name 6 and query 6 in here, which leaves us with 5 different configuration files that will be created through our automated script. How do these files look like though? Let's go through one example. Using cf name 1, the create.cf.sh script will create a file with, we'll run an example test.cf on here, a user, which comes from a secret, password for the database, which comes from a secret as well, password. Then we have a host's name, and the host's name is the address of your database. Next is the database name, which in our case is Postfix. Next is the DB name, which in our case here is Postfix. Followed by port, and again this port comes from the file on our left. Last but not least, we have the query, which is in our case for query 1, this whole statement. In the end, this is how a cf configuration file will look like. It will contain all the information this file needs to connect to the database with user and password and pull the information of a user. In our example for the query, we can see that the information that's being pulled is for %s, which stands for the current user, which is requesting to send an email and whose status is active. We will take another look at one of these files once Postfix is fully deployed. Great. Now let us have a look at the config map, or rather the script that creates these files. At first, let us write and quit the config map, and let's do vim postfix create cfs.yaml. Paste, and we'll walk down from the top. We have a kind config map. The name is init script, and the config map is deployed in the namespace mail server. We create a file, create cfs.sh, signified by the pipe at the end of the line. The file is a bash script, and we start with the allocation of a variable called number of lines, or no line. We pull all environment variables, we grab everything that contains CF name, and we count the amount of variables we find. That is what number of lines means. Then we start a for loop with 1, and we go through this loop as many times as we find CF name variables, environment variables. We create a file, and we use the CF name with the extension $1. Let's say we start with a number 1, then we would pull the value of CF name 1 in here, and that will represent the name of the configuration map, the database config map. Then we add to this file the user. We pull this out of the environment variables, and we base 64 and decode it. We do the same with a password. Hosts, we pull from the environment variables. I've shown that before. You still see it on the right how that will look like. We have the database name, and the port is out commented. We don't need that actually. And then we declare, or we pull the query. And that's already it. This variable, or this script rather, runs as many times as we have environment variables called CF name in this container. And that is the startup script that creates as many database connection files as you want. After these files are created, we had all these sed commands in the script we went through previously that are applied to the main.cf. So let us look at the main.cf configuration map next. At first, we're going to write and quit, and we'll bring up the vim postfix main.cf.yaml. As we bring in this content, on the right hand side, let's quit, and let's go back to the top. We will not walk through the full file. The important things we'll highlight here, but there are so many options that we will not be able to cover all of them here in this video. If you are interested to find out more about the options and the configuration possibilities you have through the main.cf file for Postfix, please feel free to visit postfix.org. Alright, let's start right at the top. Again, we have a config map. It is called Postfix, and the namespace is mail server. The file that we create, again signified by the pipe at the end of the line, is called main.cf.template. If you go back to the website I mentioned earlier, tosetti.blog, you will recognize that there were two options to build a container for one replica only, or for multiple replicas. I am using multiple replicas, which is why you find a name called main.cf.template. Let's walk down in the script to the first active line, which is compatibility level 3.7. We'll ignore that and move on to the next active line. You will recognize this line. The path should look familiar as we mounted it earlier into our container. I strongly recommend those folders and this folder to keep that as it is. If we move further down the file, we keep the details as they are. Data directory, mail owner, there is no change. We get to an entry called my host name. Behind the equal character, you see the entry mail at ID. If we look back at the script from the init container, and I'll show that above me here, we see that this entry will be replaced as part of the Z command. The at ID at is replaced with the server ID. The server ID will be something like postfix dash followed by a random number letter combination that Kubernetes assigns to each pod through the deployment. We will see that later, but we see now where this script modifies some of our entries in the main.cf. If we scroll further down in the file, we see that my domain is out commented, which please keep it that way. As I will manage virtual domains in my database, we cannot use this entry for localhost. If you do, your setup will not work. Next, we'll get to my origin, which we will not change. We get to a section called Receiving Mail. The first entry is inet interfaces. We will set this variable to all. You can limit this variable later to something you're more comfortable with, such as IPv4 or whatever else you might want. But I will keep this entry to all. As I do not have a proxy, I will skip the next variable and keep everything out commented as it is. Under my destination stays rejecting mail for unknown local users. You can reject an email for users that are not part of that list you can define. My structure does not require this entry, but I strongly suggest that you use this feature if your postfix is exposed to the internet. Next is trust and relay control, which we will set up. My network style class is the first entry that I want to define. You can define my networks manually, but class should work fine for my implementation, so I will not change that. Alright, I have no relay domains, so I will skip this part, which brings us to the internet or intranet section. We get to the relay host. I will not define the relay host here. For me, that comes a bit later. I will need one and will use one. However, I will not define that in this section here, which I have this set up a little bit further down in the file. The next section allows you to reject unknown relay host users. I will do that in a way, but not with the option right here. I am strongly recommending you use this feature again if you have your email relay exposed to the internet. This is a must-use option. Alright, I'm not modifying anything under input rate control or address rewriting or redirection. We will skip over everything down to the alias database. And again, you can see the alias maps between the @ signs is out-commented. However, we are creating an alias database. This entry right here is replaced by our init script discussed earlier in this video. Next, we have an alias database, and again, that both of these entries reference the same CF file. That works fine and can be set up that way. Only if you have externally managed databases for users, you might have to change that approach, and under alias database, you would then have to replace it with another database connection file. Please consult the documentation on how to set up your postfix in that way. Further in this section, we find the recipient and delivery to mailbox. We will ignore that section as our delivery will be handled through the LMTP protocol. If we scroll further down, we'll find the junk mail controls. Junk mail controls. There they are. We will not do any header checks, so we will skip the junk mail controls, and we will also leave the fast ETRN service section untouched. Next, we get to the software version. Each time you contact a server, you must authenticate, which starts with indicating who you are. What is your server name? That is the SMTP banner. We will keep these values as they are, as they indicate the host name, which is your pod name, and mail name. In the next section, parallel delivery to the same destination, we will not make any changes and leave those values untouched. Next, we get to the debug control and keep all the settings as they are as well. When we get to the install time configuration information, you can see there are a lot of settings you could change. I suggest to leave these values as they are. If you know what you do, sure, but otherwise work with the standards. As I indicated before, Postfix has very comprehensive configuration options, so consult the documentation if you wish to learn more. Then we get down to the entries I added. We start with biff equals no, which turns off notification for users if a new email arrives. Next, we get to the append.mydomain. I don't want to add the domain. Mailbox size limit is unlimited. Next is the message size that I can send through my mail relay, or that I allow sending through my mail relay, which is about 8 megabytes in size. Next, we have the SMTP UTF-8 enabled. We set that to no. And the next thing is, and that's an important one, the mail log file is going to be output to the def std output. That allows us to use the kubectl logs command and see what's happening within the container. I specify the debug peer list with SSL auth mail server svc cluster.local and SMTP mail server service cluster.local. Next, we get to the virtual controls or virtual user settings. As I mentioned earlier, I'm managing all users in a virtual setup in a database. That way I can manage them separately and I don't have to worry about creating users in a container. That would be a nightmare. As you can see, the first line in this section is out-commented. However, our startup script, particularly the set part of the init script, will find and replace this section with a database connection file which allows us to pull in the data and provide the right value to Postfix to do its job. Next, we have the virtual mailbox domains. The out-commented line here was used during my testing, which is not necessary anymore. What we need is the virtual mailbox domain, which is localhost. Next, we have the virtual mailbox base, which is /mail. That's where all the mail will be mounted, and that's all we need here. The virtual alias domains, we also don't need that piece of the instruction set. Then we get to the virtual mailbox maps. Again, this part, even though out-commented, will be found and replaced by the Z script or Z part of our script, init script, and we can then add the corresponding connection file to our database and pull the right value in. Next part is the virtual transport. This is an absolutely crucial part of the configuration. We will later on configure and set up Dovecot. Dovecot will receive the emails through the LMTP protocol and then store all the emails in the inbox for the user. That is why we specify here the virtual transport. So every email for a virtual user will be transported through the LMTP protocol and will be handed over on port 24 to Dovecot to be stored in the database. We will keep that in mind when we set up Dovecot, and we will refer back to this part of our setup. Next, we have virtual UID maps and virtual GID maps. These two values are absolutely crucial to specify, as we will otherwise run into challenges handing over our emails to Dovecot. The next section governs incoming connections. However, these are the incoming connections when your Postfix instance is exposed to the internet and receives emails for your own domain. So want to make sure that SMTPD TLS auth only is set to yes, which ensures no connection without encryption is accepted over the server. I define the certificates and key, which are a replica of the Nextcloud certificate we created earlier in this series. I define the log levels and mount the DH2048 and DH512 PEM as well. If the name DH1024 seems confusing, the best practice of choice to quote the Postfix documentation is the use of the 2048-bit prime, which is fine despite the 1024 in the settings name. As you can see, you can also reject certain emails or senders, which are outcommented in my case. I mentioned earlier that my mail service provider filters spam for me, which allows me to reduce the amount of processing on my own server. The next step is to define any outgoing connection. These configurations govern the submission of emails from my server through my mail relays to the receiver. Again, I define the TLS security level, log levels, and certificates, followed by some for my implementation important entries. I activate the sender-dependent authentication, and I do not allow any anonymous or plain text authentications. Authentication is a must and will be enforced. Then I specify the sender-dependent relay host maps. That allows me to use several mailboxes and send emails through the relay that they have been received from. Let's say I get an email through Outlook.com. The email that I'm sending out would be through Outlook.com, where if I received an email through Gmail, I would use gmail.com's mail relay to reply to that message. As you can see, the next four values are outcommented. Our startup script, more precisely the Z commands, will find these values and replace them with the final version and the correct database connection file. That query in that file will make sure to pull the values from that database we need in order for Postfix to fulfill its job. Following the sender-dependent relay host maps is the SMTP generic maps option. This map is a rewrite function that changes your email from Manuel@localhost to Manuel@outlook.com, for example. The SASL password maps contains your login details for your mail relay that you intend to use. Username and password, for example. Or, in some cases, API keys. The last option in this section is the relay host. You might or might not remember I said earlier I will not modify the relay host higher up in the file. In this section is where I will replace this value with the final value I want to use for my Postfix installation. Lastly, there are a few rule references from the master.cf file I outcommented. I do not need these options currently, but I will review them going forward, and I might apply some at a later point. How this configuration works is that you define a variable in the master.cf, like for example MUA client restrictions, and advise Postfix to look for the values or configuration in the main.cf. In the main.cf, you specify the configuration parameters for these variables, such as shown here. Defining these settings in the main.cf makes the configuration much easier to access and change in the case of a virtual machine or bare metal. For a containerized environment, that is not that much of an issue, as these containers would have to be restarted or updated through a rolling update. As we are through the main.cf, let's look at other options and files we still need. Next, we will look at the master.cf. So let's bring in the postfix master.cf.yaml. Let's go back to the top and take a look at the file. We have a kind config map. The config map name is master, and it's going to be deployed in the mail server namespace. The configuration map represents a file which we can recognize by the pipe at the end of the line behind the colon. You will see a lot of outcommented lines. We will go to the first options here. We have the SMTP active, init, and the settings. We have the submission, which are set up, postfix submission, level encrypt with ensuring encryption. Next is the SSL authentication, which we need. We say a yes, and then we have the reject unlisted recipients set to no currently. That will change later on as well, as I will try to harden the security around Postfix as good as I can. Then we move on to some of those restrictions that we saw at the end of the main.cf that were outcommented. As you can see, the setting is called SMTPD client restrictions, and the variable is called MUA client restrictions. The settings, as you've seen a few minutes ago, are set in the main.cf. This variable here just refers back to the main.cf, where the value will be found and the options will be applied. The same counts for the next two options, which are set here as well, also with a variable. If we scroll further down in the file, we also see submissions. As you can see, we have one option up here in line 27, which is called submission. The other one is submission S. One stands for the unencrypted port, port 25. The other one for the port 587. We will try to use the TLS encrypted 587, and submissions takes care of submitting emails from your own server to another mail relay or the final recipient of that particular email that you're trying to send. Other than that, most other options in here are not changed and are by default or are the default for the settings within the master.cf. I will deploy Postfix with these settings and ensure the application is running as desired. Going forward, however, I will change some of the settings to ensure the use of encrypted connections exclusively, as well as user authentication when trying to send an email. That further tightens security and ensures no abuse of my mail relay. With that being said, let's now write and quit the file and move on to the next one. We do have 5 more files to review. The first one is the postfix secret. So let's bring in the file postfix secret.yaml. This secret contains the postfix user, which I need to access the database, as well as the user's password. It is a really simple opaque secret which contains the key value pairs, postfix user, and the username base64 encoded, and the postfix pass with the password base64 encoded. We'll take a look on how to create those base64 encoded usernames and password right now. For that, we jump over onto the right side of our screen. If you have a username, and we're really going to take a very simple example, we say our username is username. You output echo username. You pipe that into base64. The result you get is your base64 encoded username. You copy that, you go back into our file on the left, and we're going to insert that. We do the same with a password. Echo password base64, and you get your base64 encoded password. As I said in my past videos, base64 is not an encryption, so whatever you enter here, don't share it. And I will add my password and username in here as well, but I also won't share that on the screen here. Alright, so I will quickly add my username and password. And that concludes the postfix secret. We're going to write and quit and move on to the next file. Before we do, we're going to empty our screens here. And next are the DH parameters. These are keys that we added to postfix and declared within the deployment. Again, a super simple opaque secret. 1 second, and I will bring this file in. Vim postfix DH parameters. Nope, that was not it. .yaml we want to call them. So you can see again a simple secret, DH parameters, mail server, opaque, and then we have the keys. Creating those keys is also super simple, and we're going to run through an example. You can create these different secrets by simply entering open SSL DH parameters and then 512. Creates a key which you can then copy, and they also have to be base64 encoded, so we'll do that. DH, nope, echo. Pipe that into base64, and we have what we need for our secret. The same goes for the 2048. That will take a little bit longer than the 512 as the encryption is a little higher. So we'll let it run through, and once that's done, we'll do the same. We'll go through the same steps and then encrypting the base64 encoding, not encrypting, base64 encoding the output. As that key was created, we'll copy it and say echo, paste the key, pipe it into base64, and we're ready to enter this encrypted, not encrypted, encoded key into our file. Obviously, I will not use both of those keys. Those were for example purposes only. I will take the keys that I previously created and add them to my secret file. As we are done with this file, we can also write and quit and exit the DH parameters. 3 more files to go and we're done, I promise. The next file is the service account. I don't want the default user to manage my email server. The access and the rights are not necessary, so we are defining a service account with its corresponding role and role binding. So let's go through that file and see what we are creating. Vim postfix svc account.yaml, and we're going to bring that in. At first, we create the service account, which is called Postfix, and it's in the namespace mail server. Next, we create a role in the namespace mail server, which is called mail manager. This role has limited access to the namespace, and other than a cluster role, it can only be used in this namespace, whereas a cluster role is available in the whole cluster. We limit the role, which is called mail manager, to the namespace mail server and allow the API, the core API group access, which is indicated by the empty quotes in the square brackets. We allow to access config maps and secrets, but we only allow these items to be read. They cannot be changed or written. Last step in this file, we create a role binding. We bind the role that we just created to the service account we created earlier. So on the bottom you see the service account is Postfix, and we bind that to the role mail manager, which we created above. Creating a service account, a role, and a role binding allows us to limit access to a namespace and increases security. As the file is complete, we can now write and quit. We also will need our right side in a second here. So we're going to remove and empty the screens, remove everything and empty the screens. And we're going to bring in the next file, which is the certificate replication. So we're going to say vim postfix certificate.yaml. As I've shown in previous videos, the file is really simple. We are saying we need a TLS certificate or a TLS secret. We have that in the namespace mail server, and we replicate from Nextcloud, and the certificate is called Nextcloud cert TLS. We need a kubernetes.io/TLS certificate, and we create empty key and certificate files. What we also need is to allow this replication, and as we will deploy everything in a namespace called mail server, you can see that on your left, we have to kubectl get secret-n nextcloud. We see our TLS secret, which we're going to edit now. Edit secret Nextcloud cert TLS, and we have to allow the replication from the namespace mail server. We're going to write and quit. The secret is edited, so now we are able to, on the left hand side, write and quit the file. We can deploy it, and we'll get a replicated certificate in our namespace mail server. Alright, we get to the last file of this deployment, which is the postfix service. Postfix svc.yaml. Let's bring that file in. And we do see that, first of all, we're going to uncomment this piece. We have a service. It's called SMTP. It is deployed in the namespace mail server. We have the selector, which is Postfix, and the role is our mail manager. We just went through that. Then we have a few ports that we declare. The SMTP unencrypted port is port 25, and the SMTP encrypted port with 587. That is already it, and as promised, a very simple file, which we're going to write and quit. Holy smokes, we have made it through the files. I would love to say let's deploy these and we're done. That, however, is not possible yet. Before we can deploy everything, we need to set up the database. That, however, is a story for another day. So let's quickly summarize. What is working? We have built a Postfix container and set up all the files we need for running a flexible Postfix deployment. What is left to do? We have to set up the database with the right tables to ensure Postfix can pull the user information it needs in order to fulfill its job in our cluster. In the next video, I will focus my attention to set up these tables aligned with our Postfix deployment and the queries we define in the database connection files. I will make sure to highlight each table with the corresponding query Postfix will make and show along some examples how that will look like. We will deploy Postfix in the next video, and from within the container we run these queries and see their results. Until then, thank you so much for watching, and I will see you in the next video.